Hello everyone, and welcome to my first Leetcode tutorial. It's Leetcode number 424, the longest repeating character replacement. So basically with this problem, we're given a string s and an integer k. We can choose any character of the string and change it to any other uppercase English character. And we can perform this operation at most k times. Our task is to return the length of the longest substring containing the same letter we can get after performing the above operations. Okay, so looking at the first example, we're given a string s equals ABAB, and we're given character replacements of at most 2. So looking at this string, we can see that if we change the two B's to A's, we can get a length of 4, A, or vice versa, we can change the A's to B's and get B, right? For the second problem, if we look at character A at index 3, if we change that to B, we also get a length of 4, right? We have at most one character replacements allowed, right? So what are some of the edge cases? Well, with this one, we know right off the bat if a string has a length of 1 or less, then we don't need to do any further operations. So we can actually write that here and just get rid of that scenario, right? But how do we solve this? We are given kind of hints and we have some constraints here. We can see that we don't need to worry about other characters. We're only dealing with uppercase English characters. And we're given another hint. We're looking for the longest substring. So this tells us that we're gonna we can use sliding window pattern to solve this problem. And typically sliding window problems are solved with 2 pointers, one on the left and one on the right, and we're gonna see what that looks like in a minute, just in a moment. Yes. All right. Okay, so this is what the algorithm looks like typically. So what we want to do is look at each character in the string and then increase the count of the character in memo for the current window. After we're done getting this count, we then need to find out the frequency of the character which occurs the most, or the character which has the max frequency. This max frequency we will then subtract it from the current window length, or the current substring length, right? Which will then tell us how many characters we need to replace. If the value is less than or equal to the k allowed replacements, then the window is valid and we can continue. All we need to do is then need to update the max length, or the longest repeating character length. This is the value we will ultimately return. Otherwise, this means the value is more than the k allowed replacements, the window is not valid, and we need to decrease the count of the character in memo at the current pointer, and then we need to increase the pointer. So let's go ahead and code that. What are some of the variables we'll need? Well, we mentioned that we need to return like a length, and we'll just call that max. That's what we're going to return, our result. We also need the window length, or the current substring that we're looking at, and we can call this temp max. We need a pointer. We'll start it at 0. That's the first index in the string. We need a memo. That's for keeping track, or the counts or the frequency of a character in the string, right? We need a difference, because we mentioned that this max frequency, we will then subtract it from the current window length, which will then tell us how many characters we need to replace. So we also need a max frequency count. So this max frequency count represents the character which occurs the most in this string. or the current window that we're looking at. So we know that we're going to need a loop because it mentions that we are going to need to look at each character. So that tells us we need some sort of loop. And we can return max because that's what we're going to be returning. Okay, so we're going to be counting after we look at each character. We need to keep track of its frequency. And so we need to check that it's not undefined first. There is a one-liner for this, but to keep things readable, we'll just do it like this for now. So we just check if it's undefined. If it's undefined, we initialize it to 0, and then we can just increment for that character. The next thing we need to do, we need to keep track of who has the max frequency count against the current, what we just currently looked at, to see if that actually is the new max. Okay. Then we need to get the length of the current window. And the way in which we do that is temp max. We have that as temp max I minus p, which is the right pointer, minus p, the left pointer, plus 1. And we are adding 1 because we are dealing with 0 indexed arrays. And now we need to get the difference. We said that this max frequency we will then subtract it from the current window length. So let's do that now. So the current window length, temp max, minus the max frequency count. And then now we need to check that if it's greater than the k allowed replacements, then we have a problem. Otherwise, we can continue. We can check our max against our current window length to see if we got anything higher or longer. So we mentioned that we need to decrease the count of the current pointer p, and then we need to increase the pointer, right? So that should be it. Let's run this and see. And there we get 4. So let's try with another b and we should get 5. We get 5. Okay, so we decreased the count, but why didn't we continue to keep track of this one? One of the reasons why we're keeping track is so that we don't have to continuously loop through the entire memo to see who has the max. We're keeping track here. But if we do a loop here, that kind of defeats the purpose of making our algorithm more efficient. However, technically, we don't need to update this because the result max is only ever updated whenever max frequency count is increased. So it's not going to affect it. We can, if we can debug this and go through line by line, and we'll see that we technically do not need to do something like max apply math object values memo. So this call here already has has a complexity of O of n, and max apply is another plus another O of n. So this defeats the purpose of actually keeping track here, or O of 1 operation here. So but as I said, we technically don't need to update this because the result, max, is only ever changed when this is increased. So we can remove that. Okay, and our algorithm will work just fine. So here we're at our drawing board, and we're going to look at the string AABABBA. And when I is equal to 0, and our pointer P is also equal to 0, we're then looking at A, right? So if we're looking at A, index 0, add that to our memo. And what do we need next? Well, we know we need to get the length of the current substring, the current window, and we can see that's 1. But how do we get that? Well, remember we had our little formula, I minus P plus 1. This gives us our temp max, or the length of our current window or substring. And using the temp max, we're going to take away or subtract the max frequency count, and this is going to give us the difference, and the difference tells us how many characters we need to replace. So using this formula, we know that our temp max is going to be 1, and the max frequency is 1, which is going to give us 0, which is our difference. And this difference, or the 0, it's less than k, so our window is valid. And so we're going to have a max result of 1. Okay. Now when I is equal to 1, we now add another A, we increase that, and we're going to get for our temp max, or the length of our window, to be 2 minus 2, which is the frequency, and we're going to get another 0, which is less than k. So we're good. Our window is good, and we can update our max result. Now when I is equal to 2, we're now at B. B is going to be 1. The length of our window is now going to be 3. Minus 2, which is going to be 1, and it's equal to k, so our window is still good. Now we're going to get a max result of 3. Now when I is equal to 3, now we're in another A, so A is going to be 3, and the length of our window is going to be 4, and 4 minus 3 is 1, which is still, it's equal to k, so our window is good. Now we get a max length of 4. Now when I is equal to 4, we're now at this B. So now B is 2, and the length of our window now becomes 5. 5 minus 3 is 2, which is more than k, so our window is not valid. And so we need to decrement at pointer P, which is A. So we need to decrement A, get 2, and we need to increase pointer P. And subsequently, I is going to be increased. So I is going to be 5. And so our window is now going to be here. Oops, let's write that properly so we can get this mouse. And I is now at 5, which is another B. So we're going to get 3. And the length of the window is still going to be 5, so it's 5 minus 3. which is 2, which is still not valid. And so we need to decrement at pointer P, which is now at 1. And at 1, it's A. So now we get 1. And we need to increase pointer P. And subsequently, I is going to increase to 6. And so our window is now going to be here, over here. And actually, A is also going to increase to 2. Once again, because it's another A. So now we have a window length of still 5. And the frequency is still 3. B is still in the window. And we're still going to get 2. Still invalid. And as we can see, we never update max result. And so since I has already reached the end, then our loop stops and our result of 4 is returned. And that's it. So we're done here. So if this tutorial was helpful to you, let me know in the comments below. If not, also let me know in the comments below. Thank you so much for watching. Take care.